have James from Figment Capital as the moderator, and we have Victor from Manta, Sinka from Delphinus Labs, Kartin from HyperOracle, Antonio from Polyhedra, and Dongmo from Stellar. Let's welcome. And now I'm going to hand my mic to James. James, is your stage now.
Okay, thank you.
Yeah.
Whoa, okay. All right, hi everybody. So thank you, Grace. Like Grace just mentioned, number one, thank you 7X for having us here. Very cool venue, great lunch. And then also, my name is Jim. I'm the managing partner at Figment Capital. We're an early stage blockchain fund, but really this is not about what we do. It's about what these guys do up here and the teams and what they're building in ZK. And so what I'd like to do just first, really quickly, if you guys could introduce yourselves, maybe just like a couple lines about what you're building, what your team name is, and then we can take it away with a couple questions, a couple hard-hitting questions.
Start from
Take it away, Victor.
Yeah. Okay, hi everyone. I'm Victor from Manta Network. Manta is right now it's a layer 2 built on top of Ethereum, and it's using OP Stack. And it's the first one used last year SDA. And on top of it, we have Universal Circuit, which is a really unique, enable Solidity developer build new use cases, without know anything about cryptography. They can just call contract and build some ZK applications. Yeah, I think right now, recently we just launched a mainnet, and it's actually yesterday. And our testnet has been running 2 months, and there's 200,000 address and 4 million transactions. Start from privacy, DeFi, and keep working on more use cases on the ZK space, and create this platform of, for all of the ZK application. Thank you.
Awesome. Hi, everyone. I'm Antonio from Polyhedra Network. Polyhedra builds the infrastructure for Web3 interoperability using zero-knowledge proof techniques. One thing we're building and we're promoting, which is largely adopted by a lot of our partners and projects, is the ZK Bridge, which offers trustless and efficient cross-chain interoperability protocol for all projects, for data transfer, for asset transfer, and for general message parsing. So about me, starting around 2018, when we were still at school, we were a group of ZKP researchers when we talked about the idea of ZK Bridge and also optimizing the algorithm layer of the ZKP protocols. Then later we founded Polyhedra Network, and here we are. Thank you.
Hi everyone, I'm Kartin from HyperOracle. So HyperOracle is a programmable ZK protocol, ZK Oracle protocol. So ZK Oracle can enable smart contract for more computation, like complex compute, like statistic compute and AI compute. And also will enable more data source for your smart contract to bring the smart contract to another level.
Hi, this is Sinka from Delphinus Lab. We are actually building a solution that people can run their WebAssembly bytecode in our virtual machine so that it does not only gives you a result, but also gives you a CK proof, which actually can help the browser application to leverage the CK technique and connect browser applications with Web3 applications.
Hi, I'm Mo from Stellar. Stellar is one of the biggest interoperability protocol for blockchain today, and some of you probably used the C-Bridge before. We processed about $15 billion transaction volume in the last year, and across 40 different blockchains. And more recently, we ventured into the ZK space, introducing a new initiative called Previous, which is a ZK coprocessor enabling smart contract to have new kind of capability for heavy and data-rich computations.
Awesome, cool. Great to meet all you guys. So I guess number one, yeah, maybe we'll start with Stellar, Mo, because when you look on the websites of all the projects that are building here right now, Stellar is the one that doesn't have a whole lot about ZK just yet. So maybe do you mind talking a little bit about what you're moving into with ZK and how the technology is kind of enhancing the offerings that Stellar is going to provide to applications as well as users?
Yeah, sure. So, Stellar was a project that was founded by a few friends starting in 2018. And we started to work on layer 2 scalability actually back in the days, focusing on state channels. And over years, the entire state channel stack naturally morphed into blockchain interoperability. And Stellar is continuously evolving over the years, and we were also looking at initially the ZK bridge to enable ZK capability for the interoperability stack of Stellar. But very quickly find out that we start to realize that the entire scope of ZK co-processing is much bigger than just the bridging. And therefore, for example, like today, if you look at the most simple example is if you look at the Uniswap, or if you look at PancakeSwap, what's the difference between these DEXs versus some of the centralized exchanges? One of the biggest difference there is that there's no VIP program, VIP trader programs in these DEXs. Why is that? Right? Because blockchains and smart contracts fundamentally are very bad at data-rich computations. For example, you cannot, if you really want to implement some sort of a VIP trader program in these DEXs, you kind of need to do accounting for every single trader, while only 5% of the total traders are actually VIP traders. Or you do on-chain direct proof of transaction inclusion using block headers, which is extremely expensive, even for the small portion of the users you want to kind of incentivize and do user retention on. Right? So this is where we feel that this kind of a data-rich and heavy computation capability is missing in the blockchain space today, and therefore reintroducing Brevius and to expand the initial scope of ZK bridging to a more generalized data analysis capability and data injection and processing capability, where you can, for any kind of a VIP traders, the VIP trader can easily generate a proof, ZK proof, stating that I have traded maybe $30 million in the last month on Uniswap, and then get a VIP status in a very cost-efficient way. The application scenario for this is very broad. You can actually do a lot more things for gaming, for social, and so on and so forth. So this is how we kind of morphed into kind of this new initiative, basically.
Very cool. So about like proving maybe certain activity, or that you've done something or performed some sort of activity over a given life or a period, and then like rewarding those users like retroactively kind of for the activity that they participated in, which is like sort of something that we see a lot in like Web 2 and in gaming and stuff like that. So it's pretty interesting. And in trading, maybe a little bit as well. Okay, cool. So I'm going to kind of jump into a couple questions we have here. As I'm sure a lot of y'all know, I don't know what the ZK expertise is in the audience, but over the last, I would say like 12 months or so, we've seen a real big excitement for ZK technology, just more broadly in the crypto space. We heard a little bit about token security on one of the speakers before, but there's also like cryptographic security, right, which is pretty cool. And as a result of that, there's been a lot of investment into ZK teams. A lot of you guys have either raised or announced raises really recently, so congratulations on that. But I guess the one question that I have is like sometimes people ask, how far along in the future is ZK? Like, is it moon math? Is it way in the future, or is it coming soon? And so I guess the first question I would ask is, when you're building a ZK project, like how do you balance the need to bring the product to market quickly, to like maybe service some needs that are needed right now, with taking the time to ensure like the security of your protocols, and specifically ZK circuits, but more broadly, like how do you balance those two things? Victor, do you want to go first?
Yeah. Sure. Yeah, I think this is really interesting question. From my perspective, like I think there's really different direction right now on ZK space. One side goes to extremely research focus. It's based on the assumption like, what if the ZK application or ZK EVM already have massive adoption, which even more adoption than existing Ethereum, and like what kind of acceleration you need, what kind of proof aggregation you need, what kind of everything you need. That's kind of the direction I think on the research side. It's kind of needed, but I think in the next 5 years or next 10 years can achieve this kind of adoption. But on the other side, I think some other projects just really try really hard to find really early users to really use ZK application or ZK use cases like Bridge, even ZK EVM or all of this new use cases, like maybe existing use cases, like, but it's actually includes ZK compared to before. So in this kind of case, like this direction is actually like, need this kind of project work really, really hard and, acquire user really aggressively. Most of the time talking the concept doesn't work, talking the backer doesn't work. It's just build a real product, and you need to have interface same as other Web 2, UX same as Web 2, like, or at least existing Web 3 product, or or also the performance like same as the existing product. That's actually really hard because it's take a lot of computation. So, but I think we try really hard on this area. I think like sometime if you try to get adoption, try to do iteration really fast, there kind of a balance between decentralized and like about the real, or to make everything using ZK, or like how's the end game and like and the game and the like basically the current use case to face the computation.
Yeah, and I guess Antonio, I want to ask you as well, because I know we spoke a little bit earlier last year, and it sounds like Polyhydra's done like, you guys have built a bunch of stuff in ZK technology. So what is your thought on like sort of how to build responsibly, but also like securely, and also getting products to market that people can play with, use, and try to find like that product market fit?
Yeah, I love a saying that Manta is always saying, because Kenny is always saying, there's no other industries focus on infrastructure so much as we do. There are so many infrastructures in the market, and sometimes people say there are probably more infrastructures than applications in the market. So it occurs to us, to Polyhedra, that, well, we build infrastructures. We were a group of researchers initially, but it occurs to us that by the end of the day, only the infrastructures with massive adoptions would be able to survive, because there are too many there. Eventually, infrastructures need to be used by applications, and we need end users. Well, as Victor was saying, we're not getting users by promoting our technology. We're not getting users by telling them, hey, who are backing us. We're getting to the users by actually proving to them that how easily and how good our product is. And that's what we are focusing on. For example, because you're saying how long we are on the journey of ZK. Well, I would say we are just getting started, but we started maybe several years ago. So we do have something. So we are on our way. One thing about ZK Bridge is that, well, people may think ZK is slow. It might be expensive in terms of on-chain cost. But actually, when you are indeed using ZK Bridge, you will find that ZK Bridge is actually super fast. Our finality for like making proofs, well, the making proofs for like for simple consensus like Binance Smart Chain could be 0.1 second. And even for full consensus of Ethereum, we're able to do that within 8 seconds. So the finality could be like, the total finality, including like on-chain confirmation, could be several, well, maybe 30 seconds. So that's one thing we're doing. I think we're doing great. We had over 9 million transactions over the past 5 months, so roughly 1.5 million every month. And we are already having over 1 million something active addresses using ZK Bridge already.
What do those transactions look like? I'm curious. Do you have any like sort of double click into like the types of transactions?
Yeah, we do. We actually do. So we know it's in the bear market. We still have to admit that in the bear market. Well, in the bear market, people tend to hold but not trade. So actually, a lot of transactions are coming from NFT sector. That's one sector we're aiming at because, well, if you look through the history, when there's depression, people focus on games, entertainment, like NFTs. So we're focusing on the NFT field. We're helping NFTs and games and metaverse make them across different chains. Because in the bear market, we have fewer users than in the bull market. So it's especially important for projects to attract users from all different blockchains. And that's what we do. That's one thing we provide for our partners. We help them to create a multi-chain setting where they're able to attract users on all different chains. And users are able to easily move their assets, move their information, move their data around. So no matter which chain you started with, you can always use any of the applications powered by ZK Bridge on any chains. And that's also the user integration in the NFT field. So that's the strategy we're taking in the down market, and it turns out to work very well.
And you mentioned that we've got a bunch of infrastructure builders up here. So maybe talking a little bit about the infrastructure of some of the teams. Like so, Kartin, you're building Hyper Oracle, and you're looking for fast. You're looking for like high performance. Maybe can you talk a little bit about like your infrastructure stack and like what you're I believe you're moving towards ASICs as quickly as possible, right?
Yeah, doing ASIC is like one of the options, but right now we think like more practically is utilize bunch GPU in the market right now, right? So back to the topic about like how to make the ZK dApp that can more accessible for people. I think this problem should separate into two parts. The first part is like how to let developer develop ZK dApp like overnight, right? Like because right now normally it takes a PhD 2 to 3 months to learn about DSL to program a ZK circuit out that's safe, and so I think this the cost for develop a ZK dApp is still very high at this moment. So in Hyper Oracle, what we do is that we try to simplify like the process to develop a ZK dApp by enable using the logic, custom logic write by assembly script, and then people can just like, developer can just like write the ZK dApp without knowing zero knowledge proof, and then compile the assembly script into the ZK WASM, and then generate the proof for the custom compile, and also use the circuit we made for the attestation. And that's the first part, to make the process to make a ZK dApp is like as easy as possible. And then the second part is like this ZK industry is so big, so we need more elaboration, cooperation to have more function into the system. And in ZK Oracle system, we're glad to have like Polyhedra and have Delphinus Lab ZK WASM to empower some usage that like is just really hard for one project to achieve. And so I think it's a really open space. The majority of them are open source. And so by combining these two factors, we can make like ZK dApp become really wild really soon.
Very cool. And for Delphinus Labs, you guys are building ZK WASM, right?
Yeah, when we actually start building blockchain applications, we find actually fascinating about the idea that code is the law, but to be more precisely, it's the code running in the Ethereum is the law, right? So when we actually trying to expanding the idea of the definition of code, we would like to have some code running out of the Ethereum to be the law as well, right? And we started with doing something called CK, like JavaScript, right? And we somehow failed because dynamic language does have some kind of feature like closure that it's not very easy to compile to CK circuits. And after that, we tried the idea about actually run and design a CK virtual machine that supports WebAssembly. And that actually works out pretty well. And I would like this virtual machine to serve as like a Python style in the CK world, because Python is not that quick, but it actually glues lots of other components, right? So, and this is our approach. We write a virtual machine that actually can be easily extend to connect other CK system and CK proofs, so that people can using us as a glue in their CK solutions, right? And bring fast adoption for the programs to leverage CK. Thanks.
Very cool. And so I'm going to change the questions up a little bit. What do you guys think about the recent proposals to augment ZK rollups security by using TEEs, trusted execution environments, for two-factor authentication? Maybe first, if anybody wants to explain what I just said, that would maybe be helpful. But or I'm happy to do it, but I mean, you guys are the speakers, so does someone want to take a stab?
Yeah, I can give a brief explanation for that. So, so basically, the idea here is that you have ZK rollup and you have prover that generating proofs. What happens if a prover or circuit has issues, and therefore, like you generate either wrong proofs that can kind of settle into wrong states, and therefore still like basically users' money eventually. So, and the idea is that okay, how about we just augment an additional layer of trusted execution environment and put all the block production logic into that trusted execution environment, and basically we only kind of confirm or finalize the block on chain when two sources matches. One is a ZK proof, the other is a TE-based execution environment. So, so that's kind of the premises of this. I think in general, this is very valuable, first of all. And coming back to the question you just mentioned, like, basically about security and adoption and kind of a launching project into public, there are just so many kind of security preparations you can do before launch, right? So TE is one, and the other is of course, audit, a lot of audits, and I know a lot of folks here spend a lot of money on audits, me included, and but what we have been championing in the community, and we have been building Bridge, which is the most targeted space for DeFi hacks to date, and we have been targeted in all around, like in all angles that you can imagine in the past. So the one thing that we have been championing in the community is to build your application or infrastructure stack in a prismatic way. That is very important. So, it used to be the case that we do audits upfront and we launch the protocol into the wild and just cross our fingers and hope for the best. And that doesn't work actually, right? So we have seen this time and again. Bugs get discovered like half year into the protocol running on mainnet. And therefore, we believe that for any protocols or any infrastructures or any applications to launch in the wild, there should be built-in defensive mechanisms like circuit breakers, like kind of a bridge invariant checkers. For example, all the ZK rollups should probably already have invariant checkers, basically saying that if there are some tokens burned on the VM side, on the layer 2 side, the matching amount token should get released on the layer 1 side and continuously monitoring that, right? So this kind of a continuous monitoring and defensive mechanism that is built into the application from day one is very important to have a smooth launch, in the sense that even if there are something that get missed in the auditing process or in the kind of internal review process, the worst case losses are always bounded. So that's something that I think we are kind of championing in the bridging space, seeing so many kind of different hacks and also kind of generally to the blockchain community.
Awesome. I feel like, Victor, you have something to say about this.
Yeah, I just feel this is really interesting question, because in the beginning of, first I totally agree what I think this is only Square doing this, right? And I think basically, I totally agree. This is to find a more practical approach, to get adoption and launch as soon as possible. But I think, at the same time, in long term, we need to understand, all of the TE is a black box, and it's also. With it get more and more decentralized, it's actually not secure. So there's some risk on top of it, and and also Squirrel is a ZK EVM, so it's finally should goes to ZK. But in the beginning, the multi-prover I think work. I don't have I can't here to judge because we are actually using OP, not using fancy ZK EVM. But we do research on multi-prover at the time, and I do think this is work. But I think for us, ZK prover is actually like a backup plan for because most of the ZK prover haven't fully audited and haven't been running for a while yet. But definitely, I think multi-prover is kind of a good solution right now.
It's essentially a multi-prover, right? Which is because you're essentially verifying that the circuit ran it the same as the EVM would have otherwise.
Sorry?
Right. You're running it as if the EVM would have run it, that you would have come up with the same solution, running the question two different ways, or the issue two different ways.
Yeah. I mean, I can't disclose too much, but
okay.
It's things under research.
Okay. Still under research. And you touched on you said multi-provers. We've heard a lot about ZK technology and that it kind of mathematically is secure. And so, we're in a crypto conference. Crypto conferences are all about decentralization. We're decentralizing the validators. We're decentralizing the node operators. There's been some discussion about whether or not you need to always have decentralization when it comes to ZK technology. So from an infrastructure point of view, where does decentralization make sense in your guys' ZK protocols, and what does it help to actually guarantee?
So guys, I'll start with a question. So for us, we were talking about multi-prover. So that's actually one very good start point for decentralization, especially in the ZK prover system. Well, it used to be very hard for ZKs to be decentralized or even to be paralleled. One thing why we came up with ZK Bridge, why that paper got selected by the committee, was that we invented an algorithm that first time in history ever we're able to parallelly compute ZK algorithms. Well, it's actually more than parallel. We call it distribute. But the difference between distributed and parallel is that for parallel computing, you have multiple machines at the same place, so they communicate with each other. You can have that in one environment with a large memory, like several hundred gigabytes of memory. Basically, they can pass information with each other quite often. So that's parallel computing. But based on that, we're actually able to do distributed computing for ZK proofs. We're able to have the machines distributed even in different corners of the world, where they are able to communicate laconically. So I think that's a Latin word, Italian word, laconic. So it means, it means silence. So there's minimum communication required between all these nodes, so that we can actually make a decentralized proof system where we're able to make the proof generation process scattered into all different machines around the world. And thus, we're able to even accelerate the proof generation speed. Because imagine, in the past, we can only do one core CPU. Now we can do 64 core CPU generating proof at the same time, as well as decentralized, distributed, generating the proof at the same time. So that's the breakthrough ZK Bridge is bringing, and that's why we are able to make such an efficient algorithm.
Actually, a really interesting idea here, because you talk about how to have a ZK and TEE as a sequencer. How about have an OP inside it too? So we got triple authentication. Yeah, it's just a kind of joke. Okay, and so decentralization I think is the core value for crypto industry. The reason why we use Bitcoin is just because it's decentralized actually. And so, yeah, with building a ZK Oracle, I care about decentralization the most, actually, compared with efficiency. So that's why we propose a new idea. It's called the proof of Oracle work. It's instead of it's kind of like POW, but instead of generate the consensus for the network, we generate the liveness for this intent compute network. So we have the agent that perform the zero knowledge proof, or OP, fraud proof, or whatever proof to the smart contract. And, but how we ensure this network is alive when the smart contract need that? So how about we have an incentivized mechanism there? We put down some token reward in the Ethereum, and then because Ethereum is really decentralized, right? And then whoever can submit the proof first, who will get that? And then so by this way, you can have a new kind of mechanism here that generate a liveness for the Oracle and do not break the decentralization and make the whole thing fully decentralized.
Can I push back on, or can I ask a follow-up question to that one? You, Kartin? So if it's is that a proof race?
Proof what?
A proof race, like. So
Yeah. Kind of like that. Whoever do it first, who will like just take the reward, right?
Yeah.
And but we don't need to worry about the winner take all, because even the strong prover, they can only run one task at one block, right? Like they cannot just run all the tasks and still be the first one.
There you go. Okay. Yeah. Actually, you like front ran my question, which was like, doesn't in a proof race, right? Which is like that we all start at the same spot and we all run to create the race the proof at the same time. Doesn't it ultimately lead to like a winner take all? Because like if I'm the best at proving, then ultimately like I will win every single time that I compete, every time that I go for a run. And so I guess in your case, what you're imagining is that there's so many proofs that are running all at the same time that like or tasks
I think
that
in
like,
the future, right? Like one Ethereum block might have like millions of the ZK proof got submitted into. So I don't worry about like the miner, the prover have nothing to do because they have a really bad machine. Because like there's always some task for them, just some simple, the one is simpler. And what they need to do is find out the position among the whole system, what's the ranking for computation resources.
Victor, how important is it in your protocol?
I was thinking, Sinka maybe want to add something more, but I mean, from our side, we just do really practical way. We just think, like start from beginning. We try to do on the application level, decentralized, and then get with the infrastructure goes better and better, and we don't have to reinvent the wheel. Do it, start from beginning, do it again. But from my perspective, I would expect some games, some credentials to actually release, and actually from user perspective, they use all of these things without centralized server on all running on the back end. I mean, it's actually really hard for applications, without server, without even Oracle. I mean, without even centralized Oracle, but not ZK Oracle. But that's actually really hard.
And Sinka, how about yourself?
Since we are actually doing tooling about a virtual machine, we do not have a plan for decentralization at the moment.
Okay.
It's open source. It's like decentralized automatically.
Yeah, I mean, so for decentralization, traditionally in blockchain really brings two value. One is security, the other is censorship resistance. I think in the ZK context, things are a little bit, are slightly different in the sense that in most of the ZK protocols like ZK rollups, ZK coprocessor like us, the security side of things are actually guaranteed by the cryptographic theory of zero-knowledge proofs, zero-knowledge 16 proofs. But still, in many cases, the reason that people are talking about decentralization in ZK, for example, shared provers for ZK rollups, are because they still want to maintain the trust-freeness, the censorship resistance side of this. But for many other ZK protocols, one additional benefit that brought by decentralization is actually efficiency. Right, so for ZK coprocessors like us, we often deal with repeated structured computation across large range of blocks, across large size of large sum of transactions or large set of signatures. So in these kind of scenarios, decentralization is essentially kind of morphed into distributed computing naturally and parallel computing in general. So this is where we are also kind of putting a lot of effort on to make the entire ZK coprocessor stack more efficient. So this is something that I guess added value for decentralization in the ZK space.
Awesome. Thank you guys so much. So we are running out of time. I think we're probably at time.
I want to throw out a really interesting question. I just remember I actually have 4 kind of way to do it. FHE plus ZK plus TEE plus OP authentication. That will be the ultimate rollup, right?
Ultimate roll-up. So we have 0 time left. So I guess the one thing I was just going to ask really quickly is is there a paper or something that you've read in the last month that you highly recommend to the group that they check out
From my side?
Yeah.
I actually didn't do like any paper research these days.
Okay.
Yeah, sorry.
Please read the Panelists paper we just published last month. It was selected by IEEE Security Committee. It's published on Twitter and also our website. It's called Plonk via unlimited distribution. Basically, we're able to make a distributed version of Plonk, which can be used for decentralized proof market, decentralized proof generation, distributed proof generation.
Yeah, I want to say that one, but you already mentioned it. And so I just promote another paper. It's really interesting. That's called Interactive Zero-Knowledge Proof that built by Panelists. And it's like a really interesting idea. Because like normally we want like non-interactive, but they made an interactive one. And actually it's like different purpose. It's not for ZK rollup, yeah, but it's like for cool thing.
I probably recommend an old paper that published by Polyhydra co-founders. And it's the Divergo proving scheme, right? It's a pretty good one, and it was actually understanding and analyzing the tricks that have been used. Thanks.
Thank you.
Well, there are a bunch of very interesting research that is coming out recently, like Lasso is something that we're looking at, and also like many of the research papers that you guys mentioned, we're also looking at it. But yeah, ZK is a very fast-moving space, so definitely kind of keep a tab on that.
Okay, awesome. And with that, we're done. Thank you, everybody, for being so attentive, and thank you, 7X.